In today's video, we are diving into one of the hottest topics in tech right now, LLMs using tools. You probably already know that large language models, or LLMs, can generate text, write code, and answer user queries. When an LLM is paired with the right set of tools, it doesn't just generate answers, it can actually transform how software works. To really understand this, let's compare two approaches: traditional software workflows versus LLM with tools workflows. Let's begin with the traditional approach to building a customer support system. A customer query comes in. This query can be of different types. It can be about a password reset, a billing issue, an account setting, or maybe some other issue. The system applies a set of business rules and logic to classify this query into one of several predefined categories. For example, password issues, billing issues, account issues. Once classified, the query may get divided into even more specific subcategories. For instance, billing issue can be divided into refund requests, payment failures, or invoice questions. Similarly, a password issue might be divided into forgot password or reset password. For each of these cases, the system either provides a pre-written response or runs a predefined workflow to generate the answer. This approach works quite well for common, repetitive problems. In fact, it can handle 75 to 80% of support requests efficiently. But this approach is not flexible. The moment a customer asks something unusual, something which was not covered by the predefined business rules or logic, then the system breaks down and starts failing. To cover those rare cases, developers need to write more rules, add more exceptions, conditional checks, and maintain more logic. That costs time, money, and energy. And even then, the system will not be able to capture all the variety of real-world customer questions. Now let's look at the modern approach using LLM workflows. Instead of relying on fixed business rules and logic, the system uses a large language model as the reasoning engine. Imagine a customer submits a query: "I'm having trouble with my billing statement and need to know why I was charged twice." To answer this query, the LLM workflow can call tools in the background. For example, it can search a knowledge base for recent changes in billing policies, it can query the customer's transaction records via an API, or it can summarize a relevant section from a customer support video transcript. The LLM then understands the context, combines the most relevant information, and generates a clear, natural language answer related to the customer's question. Because the LLM is understanding real-time data using external tools, it can handle different varying customer queries that a rule-based systems usually fail to manage. This makes the LLM workflow flexible, scalable, and context-aware. You no longer need to write thousands of rules for every possible scenario. Instead, you simply provide the LLM access to the right tools, like search, APIs, or transcript processors, and it dynamically generates the best solution for each customer. Now let's take a closer look at how to build a modern LLM with tools workflow for customer support, using YouTube video transcripts as the source of knowledge. The goal is to build a system that can read and understand the content of a video and then provide answers that are accurate, relevant, and easy to understand. Let's break down how this works step by step. The first step is simple. The user provides a YouTube video URL. This is the starting point for our system to know which content to analyze. Once we have the video URL, the system extracts the transcript of the video. This is an important step because it converts spoken content into text that the system can read and understand. We store this transcript in the program's context so that the LLM can refer to it anytime when answering questions. This is what makes the system context-aware. It's not guessing, it's reasoning based on real content. After the transcript is stored, the user can ask any question related to the video. For example, they might want details on important topics covered in the video, or they might need some clarification on the concept in a tutorial, or details about a specific example mentioned in the video. The next step is to create a full prompt for the LLM. We combine the transcript and the user's question into a single input, so the LLM has all the context it needs. This allows the model to reason intelligently, rather than just generating generic answers. The prompt is then sent to the LLM. Here we are using Grok as our reasoning engine. The LLM reads through the transcript, interprets the question, and identifies the most relevant information. It then generates a clear, natural language response that directly answers the user's query. Finally, the system delivers the answer back to the user. Since the LLM is reasoning based on the actual context and reasoning dynamically, the response is not a pre-written script, it specifically addressed the user's question. Let's go into the code and understand how this YouTube video transcript agent works. I'll explain the program step by step so you can understand the flow clearly. At the start, the program imports all the required libraries: YouTube Transcript API for fetching video transcripts, Grok for interacting with the LLM, and dotenv to securely load API keys from a.in file. We then load the Grok API key and LLM model from our environment variables. This API key lets our program communicate with the Grok LLM. If the key is missing, the program stops and reminds us to set it up. Next, we initialize a Grok client and create a simple context storage system using the agent context class. This context stores the transcripts of YouTube videos we extract and the chat history between the user and the agent. This context is important because it ensures the LLM has all the information it needs to answer questions accurately and keeps track of previous interactions. When a user provides a YouTube URL, the program first extracts the unique video ID using a regular expression. This ID uniquely identifies the video and is used to fetch the transcript. The utility function fetch YouTube transcript is used to get the transcript for the given video ID. But before fetching, the function checks if the transcript is already stored in context transcripts. If yes, it reuses the stored transcript to save time and avoid unnecessary API calls. If no cached transcript exists, the function uses YouTube Transcript API to get the transcript. It tries multiple languages to ensure the transcript is available. The API returns the transcript in segments with timestamps and text. The function converts each segment into a readable format. This formatting makes it easy for the LLM to reference specific parts of the video. Finally, the formatted transcript is stored in context transcripts with the video ID as the key. This allows future queries to use the transcript directly without fetching again. After storing transcripts, the user can ask any question about the video. The Ask Agent function takes this query and builds a full prompt for the LLM. It includes all stored transcripts, the chat history so far, and the new user query. This combined input is then sent to the Grok LLM, which reads the context, reasons over the information, and generates a natural language response. The response is added to the chat history so the system remembers it for follow-up questions. This makes the conversation context-aware and dynamic. The process user prompt function is the core interactive loop of the YouTube video transcript agent. When the program starts, it shows a friendly welcome message. It also tells the user how to exit the program. The loop runs continuously to handle multiple user inputs. The program stops if the user types exit. It prompts the user to type either a YouTube URL or a question. If the user types a URL, the program calls the transcript fetching function. The transcript is fetched and stored in context for later use by the LLM. If the input is not a URL, it is treated as a question for the agent. The function ask_agent sends the query along with all stored transcripts and chat history to the LLM. The LLM generates a context-aware, natural language response and the agent's reply is printed to the console for the user to read. By running this loop asynchronously, the program can handle fetching transcripts and calling the LLM smoothly without freezing. This system is flexible, context-aware, and dynamic, meaning it can handle multiple videos, multiple queries, and even follow-up questions without requiring any pre-written rules. This program leverages real video content, LLM reasoning, and tool integration. This allows it to provide accurate, natural responses to a wide range of questions. Now we'll show a live demo of this program, where we input a video URL, ask questions, and see the LLM generate answers in real time. Let's run this program. The console shows YouTube Video Transcript Agent. Type exit to quit. This is our friendly welcome message. Now let's give it a YouTube video URL. The program automatically extracts the video ID, checks if a transcript is already stored, and then fetches it from YouTube. You'll see a message like, transcript fetched. Stored in context. Now the video transcript is saved, ready for our LLM to answer questions. Next, we can ask a question about the video content. For example, what are the main steps to build an LLM workflow? The program takes your question, combines it with the transcript, and sends it to the Grok LLM. After a few moments, the agent replies with a context-aware, natural language answer. This response is generated dynamically based on the video transcript. You can even ask follow-up questions, like, can you summarize the workflow in simple terms? Since the LLM remembers chat history and context, it can answer naturally, keeping the smooth conversation. You can also fetch transcripts from multiple videos. For example, let's add another video. Again, the program fetches and stores the transcript in context. Now the LLM can answer questions related to both videos. The LLM will reason over all the stored transcripts and give a precise, combined answer. If the user types an invalid URL or a video without a transcript, the program handles it gracefully. You'll see a message like, error fetching transcript, invalid YouTube URL. When you're done, just type exit and the program ends. This closes the loop and ensures a smooth experience without any errors. In this demo, we've covered fetching transcripts from YouTube videos, asking questions about the video content, follow-up questions with context awareness, handling multiple videos, dealing with errors, and exiting the program safely. This shows how LLM with tools workflows can create a dynamic, context-aware, and intelligent customer support experience based on video content. If you found this helpful, don't forget to like the video, subscribe for more insights on LLM workflows, AI-powered tools, and building intelligent agents, and hit the notification bell so you never miss an update.